How can we make construction sites safer? In this episode of the Advancing Excellence podcast, we explore this critical question with safety innovation expert Scott Greenhaus. Host Janice Clines and Scott dive deep into his recent article from the International Concrete Repair Institute's Concrete Repair Bulletin, discussing the future of workplace safety in construction. Now, let's get to work and build a better, safer future together.
Hello, everyone, and welcome to another episode of the Advancing Excellence podcast. I'm your host, Janice Clines, and today we're diving into a critical topic that impacts every corner of the construction industry, workplace safety. Joining me is Scott Greenhaus, a renowned expert in safety innovation and a leader in advancing safety practices in construction. Scott recently wrote an article in the International Concrete Repair Institute's July-August Concrete Repair Bulletin, and today we are discussing this article in more detail. Scott, welcome to the podcast.
Thank you.
So my first question for you, Scott, you've been a strong advocate for energy-based hazard recognition. Can you explain what this approach is and how it differs from traditional hazard identification?
Sure. Energy-based hazard recognition, it's relatively new to the construction industry in terms of being used in practice. But it's about starting with looking at the source of the potential harm and not just what is visible to the naked eye when you go out in the job site. So instead of asking, say, what hazards do I see, we ask what form of energy might be present and how could that energy be released in a way that can hurt someone. So this includes mechanical energy, electrical, thermal, chemical energy, hydraulic, any energy that if it's uncontrolled can exceed a body's tolerance to absorb that energy. And traditional hazard identification tends to rely on checklists and known conditions. And that really works for routine work, but it can miss hidden or changing risks. So an energy-based approach is more universal, it's more proactive, it applies even when the task is new, when the conditions change or hazards aren't obvious.
Okay, so why is it so important to focus on the energy sources behind workplace hazards?
Well, the reason it's important is because it focuses on the fact that every serious injury comes down from an uncontrolled energy transfer. So let me repeat that. Every serious injury is from an energy transfer to the body that is in excess of what the body can absorb. And we understand where the energy is, when we understand where it is, how it could be released, who might be exposed to this energy release, we can eliminate it or isolate it before the work begins. And this can lead to stronger controls and better decision in the field. And ultimately, we can end up with fewer of the high consequence incidents that occur out there.
So in your article that you wrote, you talk about the energy wheel, and it's a fascinating tool. Can you walk us through how it works and how it helps identify and categorize energy sources in the workplace?
Okay. Well, the energy wheel, it's been around for a little bit now, but it's a simple, but it's a powerful way to kind of visualize how we can organize our thoughts and our views around hazard recognition. So I'll tell you what's included in the energy wheel. So there's mechanical energy, electrical, thermal, there's chemical, hydraulic, pneumatic, radiant, biological, and gravitational. These are all energy sources that we start to think about. And so instead of relying on checklists, the energy wheel prompts a structured conversation around, is this energy present here? Is it stored? Is it moving, capable of being released? And that process helps uncover both the obvious hazards like a moving equipment, but it also addresses hidden hazards like stored pressure, suspended loads, or say residual electrical energy. And what makes this tool effective is that it connects identification into action. And once we identify an energy source, the next step is decide how we can control it, eliminate it, isolate it, or manage the release of this energy before anyone is exposed. And in that way, the energy wheel doesn't just, give you a catalog of hazard. It helps us think a bit more critically and communicate more clearly, putting stronger controls in place before the work starts.
Okay. So help our audience understand, what are some examples of energy sources in construction that are often overlooked but pose significant risks?
Well, in construction, the most serious risks come from energy sources that aren't that obvious because they're stored, or they might be indirect, or we could take them for granted. So let's look at some examples, like stored mechanical energy, tension in post-tensioning tendons, or springs, or compressed components, and like compressed air. When that energy is released unexpectedly, consequences can be really severe. Another example is residual electrical energy might be missed. So when equipment is powered down, but you might have capacitors, generators, or temporary power systems, they could still carry enough energy to cause serious injury if they're not properly isolated. Another example would be hydraulic and pneumatic energy, which are especially dangerous because pressure can be trapped even after the shutdown of the equipment. So a sudden hose failure or a valve release can turn a stored pressure into a high energy projectile, or potentially even an injection hazard. So these are the kind of hazards that energy-based thinking helps expose. And by focusing on where the energy is stored and how it could be released, our teams can do a better job of recognizing high consequence risks before they turn into serious incidents or fatalities.
Okay. So let's talk about direct controls and how they mitigate hazards. What exactly are direct controls and how do they work?
Okay, good question. Direct controls is how we control the energy source itself. So instead of trying to manage a worker behavior, relying on warnings or PPE, these direct controls eliminate the energy source itself, or isolate it, or prevent its release. So the way they work is they want to break the pathway between the energy source and the worker. So if the energy can't move, or can't be released, or can't reach someone, the hazard is goes away. It's effectively neutralized. So in practice, what does that mean? Well, it's de-energizing, locking and tagging out equipment, lowering or removing suspended loads, for instance, bleeding off hydraulic or pneumatic pressure, installing physical guards or barriers so you can't fall off the edge of a building, redesigning the work so the energy isn't present in the first place. So eliminate it, and then when you don't have to protect against it.
Okay, so
So,
when direct controls aren't feasible, how can alternative controls be effectively implemented?
alternative controls don't remove the energy source, but they can reduce the likelihood or severity of exposure. Um, so you could use distance, positioning, sequencing of the work, spotters, exclusion zones to keep people away from the work area, or even remote operations that all keep the people out of the line of fire. So if we have clear procedures, permits, and training, and then we support those controls by providing a definition of how work is to be done and what conditions must be met before we proceed. And keeping in mind PPE, personal protective equipment, comes last. That's the final barrier, not the primary defense. So ultimately, the goal is the same: control the energy and protect the people. And if we can't eliminate the energy, we have to control the exposure in a way that's, really deliberate, it's disciplined, it's appropriate to the risk that we're involved with.
Okay. So, high energy control assessments, HECA, is a key component of energy-based hazard recognition. Can you explain how it works and why it's so effective in assessing and controlling high energy hazards?
Sure. Well, high energy control assessment, we call it HECA, and it builds on the energy-based hazard recognition that we've been talking about, and it focuses specifically on the tasks where the potential energy release could cause this thing we call a SIF, serious injury or fatality. And the process really starts by identifying the high energy sources involved, as we described, mechanical, electrical, hydraulic, and ask the question, if this energy was released, say unexpectedly, what would happen? And then through the use of HECA, it tests the controls themselves. It makes sure the direct controls are in place to eliminate or isolate the energy. And it asks whether, this is really important, the controls will still work if something goes wrong, whether conditions change, or someone makes a mistake. So they have to be foolproof. Even if somebody makes a mistake, the direct controls have to work.
Okay. So, how can construction teams use HECA to improve safety in their projects?
Well, they could use it by applying it at the moments that matter most. It's before the work begins, so it's part of the pre-planning process. It's especially effective for activities like lifts and working at height, energized systems, heavy equipment operations, or any tasks involving mechanical or hydraulic energy. So the HECA, where we're really comparing how many high energy risks that are out there, how many we have direct controls for, and how many we might have missed. So the teams have to confirm whether direct controls are in place to eliminate or isolate the energy, and if they're not feasible, whether we have alternative controls. And I think what's important about this is using HECA when we're looking for the high energy controls. It creates a pause in our operations so we can verify the controls are in place. So we're not assuming they're in place. They have to be checked and verified. And exclusion zones need to be confirmed, and make sure that we have stop work authority that we reinforce with the crews should should the controls not be in place when they should be.
Okay. So, research shows that some hazards require more cognitive effort to recognize. Can you explain why this is and how structured processes like the energy wheel help address this challenge?
Yeah, so that's a good question because it gets into how our brain works and how we perceive risks. And some hazards are harder to recognize because they're not obvious. Our brains are really good at spotting visible, immediate threats, but we really struggle with hazards that are hidden, that are stored, delayed, like stored energy, gravity, pressure, residual electrical charge that we described. And if we could in order to recognize those types of hazards, it requires more cognitive effort than things that are right in front of our faces, like the edge of a building that we start to feel queasy in our stomach, that we might fall off, and we know what the result of that would be. So when we use the energy wheel, we could reduce this cognitive load on our frontal cortex of our brain, and instead of relying on memory or intuition, we could externalize that thinking, and it prompts the teams to categorize each category of energy and ask targeted questions about whether it's present, whether that energy source is present on the job, how it's stored, and how it's released. And I think most importantly, it could help experienced workers avoid complacency and give the less experienced workers a really clear framework for recognizing high energy hazards.
So, your article mentions the limitations of traditional safety metrics like TRIR. Tell our audience what TRIR is and why do you think it's not an effective predictor of serious injuries and fatalities?
Yeah, I think this is a really important point, and I know I've changed my thinking about TRIR, which is total recordable incident rate, over the years, and made me really rethink, what effort we put into recording and managing our safety programs to TRIR. Because TRIR was designed to track recordable injuries, is not designed to predict serious injuries and fatalities. So it measures the frequency, but not the severity. And these things are really different. So most recordable injuries are low energy events. So that could be strains or minor cuts or slips. And serious injuries and fatalities, as I mentioned before, always involve high energy releases, but they're low frequency. They don't happen very often. And the presence of a minor injury, a cut, a bruise, will tell us very little about whether high energy hazards are actually under control, because a TRIR, it looks backward. It's what we call a lagging indicator, and it reflects what's already happened, not what can happen next. So,
That's
a
interesting.
company can have a low TRIR, but still be one, uncontrolled high energy event away from a catastrophic output.
Okay. So how can organizations shift their focus to more meaningful metrics like HECA scores?
Well, metrics like HECA, which measure the strength of controls around high energy work, are far more predictive of serious injuries and fatalities. So it's a move from TRIR to HECA and managing high energy controls. And to your question, organizations really have to embed these metrics into everyday operations. So using HECA continuously on high risk tasks, and then tracking their trends to see how effective they are. And if a job site scores poorly, it's a learning opportunity. It's not a failure.
Okay. So how does high energy based recognition align with the Construction Safety Research Alliance framework?
Yeah. So I just want to point out to your listeners, the CSRA is under the auspices of the University of Colorado, and they do research in the construction safety. And their research has shown that these SIFs, or serious injuries and fatalities, are driven by these high energy hazards and by failures to control those hazards. So tools like the Energy Wheel, HECA, and direct controls have been developed and implemented by the academics at CSRA and industry partners, large construction companies that focus on high energy exposure, the control effectiveness, and really the need to intervene upstream before the work begins. So the work that CSRA is doing is really good work. It helps to explain why organizations need to focus on high energy hazards and energy approaches, and gives us a map as to how to consistently and effectively use this in real construction environments.
So what steps can organizations take to integrate these methodologies into their safety programs?
Yeah, that's a good question, and this is the answer I've given to in many of other podcasts together. It's all about leadership and leadership alignment, and pointing the organization in the right direction, and making high energy controls, making that really important to the organization. So, and I would like to point out that those that are practicing the high energy management, it gets incorporated into the existing system. So it's not just another layer of paperwork. Energy Wheel and HECA can be built into the existing pre-task planning processes, job hazard analysis, lifting plans, permit to work processes, any of that stuff that's really important can keep doing what you're doing, just add this component to it. And training to that is critical. Supervisors and crews must be trained, and they have to be trained to recognize energy sources, understand how energy is released, and evaluate the strength of their direct controls.
Okay, so you just touched on a little bit of it, but my next question, in your experience, what are some key elements of proactive safety culture?
Well, again, the first key element is leadership behaviors. The leaders consistently need to ask about the risk, energy sources, control effectiveness. It's not just schedule or production. That they have to get. You're out in the field talking to the crews. Make an effort to talk about, are these controls in place? What risks are in place? And it's not only about schedule or production. Because people will respond to what their bosses talk to them about. So another critical element of this from a leadership behavior perspective is being psychologically safe, so the workers feel empowered. They can speak up, they can question controls, they can stop work when conditions change, without the fear of blame or any kind of retaliation. And I think when these elements come together, safety becomes a much more normal part of how we work and how work is planned and executed. And the serious injuries and fatalities can become far less likely.
Okay, so you touched on how leaders can foster a culture, but I'd like you to leave one last thing with our audience and how they can prioritize both physical and energy-based safety.
Well, I think the leaders can foster this kind of culture by making energy assessments visible, making them relevant in everyday decisions, not just after something's happened, an incident or an audit. And as I mentioned, that starts with leaders talking about these things in the field. What energy is present? How's it being controlled? In addition to talking about PPE and conditions that are on the field, and reinforces that safety is about controlling risk at its source. And the leaders can set the tone, and they could do this by prioritizing direct controls over, say, a procedural workaround. And when schedule and costs are adjusted to allow for, say, de-energizing or isolating or redesigning the work, it really sends a powerful message to the crews that controlling energy comes before production.
Okay. Well, thank you, Scott, for joining us today and sharing your knowledge on this very important topic. And thank you to our listeners for tuning in to the Advancing Excellence podcast. If you've enjoyed today's episode, don't forget to like, subscribe, and share this podcast with your colleagues. For more resources and insights, visit aoeteam.com. We will also link any websites referenced during the podcast in the description. Until next time, stay safe and keep striving for excellence. Thank you, Scott.
You're welcome. Pleasure.
Thank you for listening to today's episode of the Advancing Excellence podcast. If you have any comments or questions, please get in touch with us at info@aoeteam.com. Don't forget to follow AOE on LinkedIn at Advancing Organizational Excellence, and be sure to subscribe to this podcast so you never miss an episode.